Black holes are one of the universe's most fascinating mysteries. Imagine a place in space where gravity is so strong that nothing, not even light, can escape. This is a black hole, a region of space-time where matter has been squeezed into an incredibly tiny space. Black holes are not empty holes, but rather objects with immense density. This density creates an incredibly powerful gravitational pull. If you were to shine a flashlight at a black hole, the light itself would be trapped by its gravity. Black holes come in different sizes. Some are called stellar mass black holes because they are formed from collapsed stars. Others, called supermassive black holes, are millions or even billions of times the mass of our Sun. These giants lurk at the centers of galaxies, including our own Milky Way. How do these cosmic monsters come to be? The most common way a black hole forms is through the death of a massive star. When a star much larger than our Sun runs out of fuel, it can no longer support its own weight. The core collapses in on itself, and this collapse can trigger a supernova explosion. This explosion is incredibly powerful and can outshine an entire galaxy for a short time. If the core of the star is massive enough, the collapse doesn't stop there. It continues to squeeze itself into a smaller and smaller space, eventually forming a black hole. Imagine squeezing all the matter in a star many times larger than our Sun into a space smaller than a city. That's how dense a black hole is. This incredible density is what gives black holes their extraordinary gravitational pull. Black holes are invisible to telescopes that detect light, X-rays, or other forms of electromagnetic radiation. So how do we know they exist? While we can't see black holes directly, we can observe their effects on the space and matter around them. For example, when matter falls into a black hole, it heats up and emits X-rays. Astronomers can detect these X-rays and use them to infer the presence of a black hole. Another way we can see black holes is by observing the orbits of stars around them. Just as the Earth orbits the Sun due to its gravity, stars orbit black holes due to their intense gravitational pull. By studying these orbits, astronomers can calculate the mass of the unseen object, and if it's massive enough, it's likely a black hole. Imagine approaching a black hole. As you get closer and closer, the pull of gravity becomes stronger and stronger. Eventually, you would reach a point of no return, called the event horizon. At the event horizon, the gravity is so strong that nothing, not even light, can escape. Once you cross the event horizon, there's no going back. You would be inevitably pulled towards the singularity at the center of the black hole. What happens at the singularity